today we are going to take a look at the binary search problem. So it's an easy one problem on the lead code, but many people are struggling with that, and there are a lot of mistakes which we are still doing through our attempts to resolve such kind of problems. That's about simple binary search, lower upper bound, some binary search by answer, and other related things. So in terms of the present session, I would like to highlight for you few tricks which I'm continuously using during the resolution of those type of the problems, and I hope that this will work for you too. First of all, let's check the problem itself. Let's imagine that we have some sorted array and we would like to search over it for some number, and as a result we should receive the position in this array of the elements which are under our search. For example, if we have the search number like 5, so in this array we should return index 2 or 3. And in case if we have the search number like 2, then we should return -1 because of we haven't the element with the value 2 in this array. And if that's the case, then we should think about it like some approach which will operate with the two indexes. Like we have the index 1 which should check this position, and the index 2 which should check the position after the end of the array. Why that? Because of we want to, like, you know, a lot of people are trying to do some things like the left bound +1, or in other scenario like right bound +1 for searching for the medium position. So, and how this will work? Like we have the our middle position, and probably it will start from here or from this one because of the array size divided by 2, and so we will also discuss how to divide. So like probably you will do that like the following way. So like left plus right divide by 2. Of course, let's add brackets here. And your interviewer will probably ask you that, hey, currently we have like the overflow of the integer, and how to solve this. So for the correct approach is better to do like left plus right minus left minus left. So that's the correct one, and so we should escape from these things, and because of it we are operating over this mechanism with like defining our right bound after the end of the array, and we are starting from the beginning, from the like element with the index 0. And so what else? And for another trick for escaping from the +1 at the left position and +1 for the right position, so we should also do the next. So that's about the correct condition. The correct condition here should be like right minus left should be always bigger than 1. That's our condition for exiting from the loop. And so, like, we are searching for the 5. We will have that for a 1 iteration, like our middle pointer will be 5, and that's all. And let's imagine that we are searching for 3. Yeah. So the first iteration will be here, and we will check if our nums, our array or nums, bigger than 5, and if not, then we should escape from this part of the array, and we should search only in this part. Yeah. And if that's the case, we will have another iteration, and probably we will have this like here. And if that's the case, then we will find the correct value. So to summarize, I would like to say that the trick here is in a few places, like correcting the correct defining of the middle pointer. Another one, correct adding the condition for exiting from the loop, and correct escape from the +1, -1 for the left and right pointer. And that's all. So let's try to write some code here. So let's do that together. I will do that on Java. Like, I have left pointer here, which will equal to 0. Another one, right pointer, which will equal to nums length. So let's define the while loop as we discussed it before. So we should do right minus left more than 1, like bigger than 1, sorry. Let's assume that we have some middle, and let's use our approach with the left plus right minus left, right minus left, divide by 2. This is for avoiding the overflow of the integer because of the array size in the most of the programming languages equal to the integer max value. Okay, so, and currently let's assume that in case if our nums middle bigger than target, then we should decrease our right pointer. It should be equal to middle, or else we should increase the left pointer. Should be equal to middle. Okay, and what we should do at the end of the while loop? We should return some value, right? So let's return it. In case if our left pointer equal to target, then we should return our left pointer, or we should return -1. And that's all. That's probably it. Let me run this code. And let me submit. That's all. It's passed all of the tests. So, and what I would like to say that using this approach with all of the tricks which we discussed before, like one of them is related to the escaping from +1 -1 for the left and right pointer, adding the correct conditions for the exiting from the loop, using this like inclusive and exclusive bounds of the search, and adding this sync for avoiding of the integer overflow helps you to build the correct solution. So it's also possible to deal with that from some Java syntax sugar approach and to run it with some predicate, but probably I will do that for you at some other session. And for today, thanks a lot for your attention, and have a nice day.